Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at the integration, specifically the volume of revolution. Now, if we have y is equal to f of x such that we have the graph that is represented here, and starting from point A to point B, if it happens that we rotate this particular graph 360 degrees about the x-axis on AB on the x-axis, we would have that figure here, which is like a 3D shape. Then the volume generated is given by Vx is equals to pi times the integral from a to b of y squared dx. That is what we would make use of in this section. Let's take a look at example 1. So the diagram shows part of the curve with equation y is equals to square root of 2x cubed plus 10. Find the volume of the solid obtained when the shaded region is rotated through 360 degrees about the x-axis. So we have our a and our b, which are the lower and the upper limit. And we have our y. So the first thing that we need to do is to find the y squared, of course. Now, so because the coordinates are already known in this case, so we are going to substitute those limits and with the y squared. So we know that our y squared would just cancel with the square root, so that we have pi times the integral from 1 to 3 times 2 times x cubed plus 10 dx. So now this is easy to integrate because we are just integrating separately, so that we have pi times 1 over 2 x to the power 4 plus 10x. Then we substitute for x with the lower and the upper limit, starting with the upper limit, subtracting the lower limit, so that we get 60 pi cubic units. And take note, I've used pi instead of its approximate value because I wanted to keep the final answer as exact as possible. Let's move on to the other section. So we are saying if we have x given in terms of f of y, such that we have the graph that we have on the right hand side from A to B, then if it happens that we have the shape rotated through 360 degrees about the y-axis on AB on the y-axis, then we would have a 3D shape that is presented on the right. The volume generated is given by Vy is equals to pi times the integral from a to b of x squared dy. Take note of the change that happens and the difference between the first equation we looked at and this one over here. Let's take a look at example 2. So we are given the shaded region here, which is rotated 360 degrees about the y-axis. Of course, it's not shown, but we have to imagine it. Find the exact volume of revolution obtained. So in this case, we can see that we have one y value and the other one is an intersection, which we do not have. So this one is similar with the equation that we looked at in our previous videos when we were covering area using integration. So to find the other intersection, we would set our x to 0. So when we set x to 0, we are going to get y of 2. So then it means that we have the limits, the lower limit of 1 and the upper limit of 2. So the next thing we do is to make x the subject of the formula, because recall from our formula, we want x squared. So we have that y squared is equals to 4 over x plus 1. Then interchanging the positions of x plus 1 and y squared, we have that Then moving the 1 to the other side, x becomes 4 over y squared minus 1. That is our x. Therefore, our x squared, when we expand that, we are going to get 16 over y to the power 4 minus 8 divided by y squared plus 1. So we now move on to integrate. So we are going to find Vy, that is pi times the integral from 1 to 2 of that. Then as we integrate, we are going to integrate this separately. Of course, we can apply the laws of indices because that would make our lives easier. We get to a point where we have pi times minus 16 over 3 times y to the power minus 3 plus 8 y to the power minus 1 plus y from 1 to 2. Then the next thing we do is to substitute the upper limit, then subtract with the substitution of the lower limit. Then as we do so, we simplify our work up until it gets to 5 over 3 pi cubic units. Great. So if you've made it thus far, congratulations. I leave you with the following task. Remember to like, share, and subscribe so that you don't miss out on any of our future uploads. Thank you so much for watching Numbers Simplified. God loves you.